In this video, we're going to be showing you three concepts of linear motion. First one is free fall, then we're going to go to average speed, and then we're going to go to acceleration. Right now, we're going to drop two objects from this tower, one being this large stick that I'm carrying, and then one being a small rock. On our planet, the acceleration from due to gravity is 9.8 meters per second. In a vacuum, everything would be in uniform acceleration, so everything would fall at the same speed. But in this video, you can see that the stick has a higher surface area, so wind resistance affects it more in the fall, so it has a little bit deviation in speed. As you can see, the rock fell a little bit faster than the stick just because of wind resistance. So from here now, we're going to move on to average speed, which we're going to measure it out and race it with Jack's bike to see how fast his bike is moving over the distance.
I'm ready, go ahead.
The point I just marked is a starting point for Jack to start racing his bike, along the 200-foot track that I'm marking right now. Since average speed is equal to the total distance covered over time interval, what we get here is that we're going to have 200 feet, or 61 meters, and then we're going to have a time interval of about 6 seconds that we record in the next videos. So Jack travels around 10.2 meters per second along this track that I'm marking. Also, shout out to Zach, who is helping us out mark this track and record this.
Ready?
Now we're going to switch to acceleration. Right now I'm cocking the crossbow and to fire a bolt at a target. The bolt's only going to accelerate as long as the string of the crossbow is affecting the bolt. So as soon as the string detaches from the bolt can no longer accelerate. It only decelerates because of air resistance.
Woo!
These concepts can also be applied in rifles. As you can see in the next video, I'm going to be using the difference in the barrel lengths of rifles to show you a difference in speed. You can see when we're firing the crossbow and the bow and arrow, the arrow stops accelerating right after it leaves the string of the bow because the force stops acting upon it. So now what we're going to be doing is that we're going to be shooting two .22 CCI caliber rifles, or well, one pistol. The difference is between these two is that the barrel lengths. This is about 9 inches and this is about 16 inches. So since acceleration equals change velocity over time interval, the time interval is going to be more in this because it has a longer length than this 9-inch barrel. So the gas from the explosion of the black powder will launch this and accelerate it for a longer amount of time. The .22 bullet down the barrel of us having it gain a higher velocity than in this 9-inch barrel because it has less time to do so. So I set up some bowling pins across the way to shoot at with this 22. Now this is going to have a lot harder time knocking down the bowling pins. I don't know if I'm going to be able to get one down, but you're going to be able to hear it hit. So I'm going to try to shoot these down with this 22. As you can see, I had 5 solid hits, yet those 2 on the right did not go down. So with the 22 long rifle, I should have a lot easier time doing this. I should be able to get one down every shot. And do the same thing with this 22, which should shoot one down every shot, like I said. As you can see, I had a lot easier time. I got all the pins down with one shot each. Well, that's the end of me and Jack's video. So, this is for you, Justin.